All right. Hi, everyone. Thanks for coming to my talk. I'm going to talk about Rails on SQLite and exciting new ways to cause outages. So between Litestack and the Rails 8 new gems, solid cable, solid cache, and solid queue, it's easier than ever to spin up a Rails app that doesn't need a database service or a Redis service or a file storage service. It's great to simplify things, but even after 20 years of deploying Rails apps myself, I was still caught out by some of the ways that things are different. So based on what happened when I built a new side project in Rails using SQLite, I'm going to cover what's different, what's new, and several ways that you can take your entire site offline or even delete your entire production database. And as we go, I'll also talk about some of the advantages of using SQLite and how those differences can help you. So who am I? How did I learn these things? And why should you listen to me? Well, I'm André Arko, better known on the internet as Indirect. A long time ago, I helped create Bundler. Today, I work at Spinel Cooperative, which is a collective of Ruby open source maintainers. We build open source tools like RV, a Ruby language manager that can install Ruby in 1 second. And we offer retainers for unlimited access to core team experts from Bundler, Rails, and more who can answer your questions and solve your problems. I've been deploying Rails applications to production since 2004, and most relevantly for this particular talk, I built a service called Feed Your Email. Feed Your Email turns subscriptions into RSS feeds. So there's no sign up, there's no accounts. You just go to the website and push a button to get an email address and a feed URL. Emails sent to that address show up in the RSS feed. Feed Your Email is really only possible for me to run as a service because of SQLite. If I had to maintain 2 or 3 Postgres instances and 2 or 3 Puma instances and 2 or 3 Sidekick instances, and it would have just been too much hassle, it would have been too expensive, I would never have been able to afford it, and I would have given up. SQLite reduced the complexity of building and deploying this service to the point where I was able to do it casually, for fun, and keep it running for both myself and for anyone else who wants to use it, while still feeling like it was worth it, even if I was the only person who was using it. So this app serves about 1 million requests per month. That number does sound kind of big, but if you do the math, it's about 24 requests per minute, or 1 request every 2.6 seconds. So we can definitely serve 1 request every 2.6 seconds off of a Rails app, even if it's a small, DigitalOcean droplet or a small cloud VM. So I run this service on fly.io, and the hosting costs me like, $10 or $15 US per month. The service has bonus features like a web view. You can share individual emails as a link with someone that you want to read the same email without letting anyone else see all of the other emails in that feed. It also has full text search if you're trying to find a particular email that you've gotten in the past. That full text search is a feature powered by SQLite, which brings us back to the topic of the talk. So how does SQLite help? Let's take a look at that. The biggest fundamental difference, where almost every other difference comes from, is that SQLite is built inside your web server process. The reason for Lite in the name is that it doesn't run in a separate process. It doesn't listen on a port or a socket. It's not running a server. You can't connect to it. All the data is just in a single file on the file system, and your web process reads and writes that file when it needs to. This is very cool. You can't have database connection errors anymore. It's great. There is a small issue with giving the web processes its own database in a local file, though, right? If you deploy your app the way that is common or usual, your production database might get completely deleted anytime your application restarts, right? If you use Heroku, Heroku just deletes and restarts dynos every 24 hours. If you run on a container service, anytime your container restarts, all of the files inside the container are deleted and they're now gone. So in a world of containers, it can sometimes be easy to miss that your new SQLite database is on an ephemeral file system and it will disappear along with the Puma process when it restarts. So this is the first and most important rule of using SQLite. Please put your database file in persistent storage. On AWS, that means using something like EBS. On fly.io, there's a similar feature called volumes, but wherever you're hosting, make sure that you keep your database files across restarts and ideally have automatic snapshots. Now that your database won't disappear at any moment, let's talk about what it means to put all of the data into a single file. So like you probably use rails.cache to store temporary data. Well, that's now inside a SQLite file as well. You probably also use ActiveJob to send emails or do slower work in the background. Well, all those jobs are now also in a single SQLite file. By default, it's the same file. All your cache, all your models, all your jobs, they're all just in one single SQLite file, which does make things very easy. You only need to keep track of that one file. You only need to back up that one file, and you know all your model data, your caches, your jobs will be safe. SQLite being in process raises a new problem though. Like what if your background job needs to update a model? Like you're probably used to deploying your background workers to a separate container from your web workers. And you can kind of see that's not going to work anymore because your background workers need to be able to read and write this same single file that your web server is also reading and writing. So since your database is now just one single file, you have two options. You can either run your workers in another Ruby process inside the same VM where they share a file system, or you can run your workers in threads inside the web process that is also serving web requests. If this is a smallish application doing 1 million requests a month, you'll be absolutely fine putting your background jobs just into threads on the Puma process. As a bonus, putting background jobs into threads can have the amount of RAM that you need because a single Rails process is now handling both web and background job requests. If you really want to scale up your application, though, you'll need to do what gets called vertical scaling rather than the more traditional horizontal scaling. Like you can't add more VMs because the other VMs won't be able to see your database file. So instead, you need bigger and bigger and bigger, just one server, and that single server needs more and more CPU cores and more RAM to handle more requests. That's definitely possible. There are servers nowadays with 128 cores or terabytes of RAM, and you can pay for them. But once you've scaled your wildly popular application vertically to the moon, you discover another limitation of SQLite, which is that it's just one file on disk. If you have dozens of Ruby processes and hundreds of threads in many web servers and background job workers all trying to share this one single database file all at the same time, there's probably going to be a lot of contention. By default, SQLite uses the file system to take out a lock on the entire database file for every individual transaction. Holding the lock, it executes any read and write queries, commits the transaction, and then releases the file system lock. Then the next query or process can take the file system lock and do the same thing. This can create a very large queue because even read-only queries have to wait in line and work one at a time to take the lock on the file system before they can execute their read query and then give the lock back. The reason for that to be necessary is that if the reader didn't have the lock, some writer might sneak in and change the data in the middle of the read, causing invalid data to be returned. To address this problem, SQLite offers a middle ground in the form of a write-ahead log. The write-ahead log, or wall log, is an append-only file where database writes are written one at a time, and then a SQLite-controlled process interleaves copies that put those write instructions into the actual database in between reads. But in the meantime, while reads are happening, you can allow an unlimited number of reads to occur simultaneously because none of them are changing the database. This solves the problem with only allowing one single read or write at a time, but it in turn comes with a cost. Now the database isn't just one file anymore, it's a file containing the database and a series of files containing these write-ahead logs that are everything that's been written And you need to back up those files and restore them together if you want to make sure that you haven't lost any data. Hopefully that's not too much trouble, but it's definitely something to think about while you are planning your backup and disaster recovery strategy. There's one other approach worth calling out at this point, and that strategy is deliberately using multiple SQLite database files. If you're not putting your model data, but also your Redis cache, also your background jobs, into a single SQLite database file, you can start to step on each other's toes. For example, if you queue up a few thousand background jobs, then writes from your web request might end up waiting in line behind all of those background jobs that need to be written. So you can create a separate SQLite file per system or per access pattern, which can help a lot with this. The most common split is one database for active record, one for the cache, and one for the background jobs, and maybe one for action cable if you use that. You can even add another database for active storage blobs if there's a lot of complexity and overhead involved in setting up S3 buckets with the correct permissions and getting files in and out of them. And if you store your files in an S3 database, you can skip all of that S3 complexity as well. Taking this approach to an extreme might even involve sharding your model data across many database files. The most extreme version I've heard of this is an application that chose to shard their model data with one database file per user. That meant every new signup created a new SQLite database file on disk, which is a little bit ridiculous, but it also meant that every individual user had a full SQLite, database available to them. So it's hard to have write contention when every user has a separate database. So now that we've covered vertically scaling the Rails server, let's talk about a couple other implications of running your application on exactly one server. The downside is there's just one server. If it goes down, your entire app is down. It doesn't slow down. It doesn't get degraded. It's just gone. There's no app anymore. If you're in a container, it's also impossible to deploy without downtime because only one container can ever have the block service with the persisted database file attached at a time. So you have to completely shut down the container you no longer want so that you can move the attached file and then start a new container. If you're running inside a VM rather than a container, you might be able to deploy without downtime by having like a local reverse proxy and you start a new Puma and you shut down the old Puma and maybe you don't have downtime. But that's how we used to deploy applications in the 2000s. So sorry, that's not great either. That said, one thing about only having one server is really great. It's very easy to find out if the server is broken. It's very easy to debug. You don't need to debug connections between load balancers and databases and Redis servers and file storage servers. You just need to debug one server. That can make your job much easier. Another implication of having just one server is there's only one place for requests. So the load balancing that you might be used to doing either between many containers or between many different locations, that's not possible anymore. You can only have this server run in one place. The good news is you probably don't need your server to run in many places because if that happens, you probably won't want to use SQLite anymore. If you ever want to switch towards or away from SQLite, the SQL gem has this great ability to read from one type of database and into another. So you can move from MySQL or Postgres to SQLite. You can move from SQLite into MySQL or Postgres using the SQL gem. I highly recommend it. There's one last limitation that we need to consider, and it's the single location, meaning that if you want local read replicas for your users in different places, you just can't have that because of this architecture decision. The best you can have is a CDN which hosts static resources but not the database itself or any of the dynamic data. Last thing, backup and replication options. The absolute all-star of SQLite backup is called Litestream. It comes in a gem. And what it does is it forwards a copy of each entry in your write-ahead log directly into an S3 bucket. If you ever have a catastrophe, if your whole server gets deleted, you can just copy the write-ahead log and the database back out of S3, replay, and you're right back to where you were when everything crashed. On AWS, this means you still need an S3 bucket, but that's much easier to set up than if it's only connected to your application. Last thing you can try, if you're feeling adventurous, is Litefs. Litefs is a super interesting software that offers full multi-primary replication for SQLite databases in more than one place. They do this horrible trick, which is to create an entire user space file system using Fuse, and they put the SQLite database inside the Fuse file system. They then intercept every file system read and write and transmit those changes to other copies of the database. This setup comes with a lot of caveats. The biggest one is the usual, distributed systems. You'll have stale reads where some users will see old data. If the primary crashes, you might lose some data. If you're okay with the trade-offs of a distributed system, and if you're okay with the idea of your database reads and writes going through Fuse, which might add additional bugs, Litefs offers a version of kind of the ultimate web application dream. In the dream SQLite plus Litefs world, you have all the advantages of SQLite and all of the advantages of a fully replicated multi-writer database setup, and any individual server can go down without causing any downtime for the application as a whole, and every user has a full copy of the application running extremely close to them. I haven't built that perfect system yet, but it feels more attainable now than it ever has before, thanks to SQLite.